So Pythagoras related sides of right triangles to other sides. The sum of the squares of two sides is equal to the square of the hypotenuse. Trigonometric ratios, which we're going to talk about today, relate the angle measures of right triangles to ratios of sides. And once again, a ratio is just a fraction. And we have these three trigonometric ratios, one being sine, the other being cosine, and the third being tangent. And these ratios are equal to the following. If we have some given angle, let's say B in each of these cases, then the sine of this angle is equivalent to the opposite side, and the opposite is the side directly across from the angle, over the hypotenuse of the triangle. The cosine of this angle is equal to the side next to the angle, it's called the adjacent side, over the hypotenuse. And the tangent of this angle is equal to the opposite side over the adjacent side. And here are these three ratios written out. What we're going to do is we're going to use information given to us in a triangle to find sides and angles. So here's a situation where we have a right triangle. We can tell by the indicated rectangle within the triangle here. We have an angle of 73 degrees, which is right here. And then we have this hypotenuse because it's opposite the right angle. And now we just have to characterize this side here. If it's directly across from that angle, it's the opposite side. But if it contains the angle, like this one does, it's called the adjacent side. So now we just learned a trigonometric ratio that said if we have the adjacent and the hypotenuse, we can use cosine. So the cosine of the angle at 73 degrees is equal to the adjacent side, which we don't know, so we'll call that x, over 6. And we're going to find x. If I wanted to find x, all I need to do is multiply both sides by 6. And so I have 6 times the cosine of 73 is equal to x. Now, in order to solve this, you're going to need your calculator, so let's get those out. And the first thing you're going to have to do is check the mode of the calculator. So if we hit this mode button right here, you'll notice that my calculator is highlighted on this thing called radian right here, and we need to be in degree mode. So what you do is you just move down to where it says radian, and then move over so that the blinking box is on degree, and then hit enter. And now we've moved from radian mode to degree mode, and we're ready to go. So we're going to quit out of this screen. And then all we have to do is type in what we see here and solve the problem. So we have 6. We hit the cosine button. We hit 73, and that's going to read as 73 degrees in the calculator. Hit enter. And we end up with 1.75 as our answer. Let's take a look at another problem. Again, a right triangle. Here's our hypotenuse, but this time we have the side directly across from the angle, so this is our opposite side, which means we're going to use a sine ratio. So the sine of the angle, which is 51 degrees, is equal to the opposite side, which is 14, over the hypotenuse, which is x. And what we want to do is we want to solve for x. Now, the way I choose to do these problems is I take and make, since I have an unknown in my denominator, I make a proportion and then just take a cross product. So I have x sine 51 is equal to 14. And then I can divide both sides by sine of 51. And I get x equals 14 over the sine of 51. We go to our calculator once again. and I'll hit 14. This time we divide by the sine of 51 degrees. Hit enter, and I have 10.01. That will equal my x value. Let's go ahead and do another one. You take and notice that x is opposite 37, and remember the side opposite my right angle is my hypotenuse. This has nothing on it, so this must be my adjacent side. So if I have the opposite and the adjacent, I'm going to use tangent. So tangent of the angle, which is 37, is equal to the opposite, which is x, or the adjacent, which is 12. I need to solve for x, so I multiply both sides by 12. And I have 12 tangent of 37 is equal to x. Again, get the calculator. So 12 tangent 37 equals, and I get 9.04. Oops. Is equal to my x value. Now we have a situation where we're actually looking for the angle. And what we notice is we have, once again, our opposite side here. And this is opposite the right angle, so this is our hypotenuse. And we know the ratio that uses opposite and hypotenuse is sine, so we're going to say the sine of our angle, call that question mark, is equal to 11 over 27, because that's the opposite over the hypotenuse. Now, unfortunately, sine is not a number. It's kind of like a square root, so you can't really divide or multiply by sine, even though it looks like it's being multiplied. So we have to undo that. When we have like a square root, we'd square both sides. And we do something similar to this. We do what's called take the inverse of both sides. So in order to do that, we say if I want to get sine by itself, we take the inverse of the sine. And that's how we write the inverse of that value. And what will happen is we'll get the angle we need by plugging this into our calculator. This inverse basically says what angle has a ratio of 11 over 27. So let's go ahead, get to our calculator. And in this case, we've got the inverse sine. Now you'll notice sine, once again, is right here. If you look in blue right above it, we have the inverse. So we say second sine, and you'll notice there's our inverse. And you have to make sure this whole fraction goes in that parentheses. So 11 divided by 27. And then we hit equals. And what's going to pop out is an angle. So that angle is in degrees. So we have 24.04 degrees in this case. Here's another situation where we have to find the missing angle. We just need to determine how these sides are related to it. Opposite the right angle, which is the hypotenuse. Sharing the side of the angle, which is next to it, so we call that the adjacent. Adjacent and hypotenuse is the cosine of this angle, is equal to the adjacent, which is 13, over the hypotenuse, which is 20. I need to get that angle by itself, and this is a cosine value, so it's a function, which means I need to take its inverse in order to get the angle by itself. So that unknown angle is equal to the inverse cosine. of 13 over 20. Once again, we'll go to our calculator and find the inverse cosine of 13 over 20. So second cosine gets me the inverse of 13 divided by 20. Close the parentheses, hit enter. We get 49.45 degrees. So let's move to our next example. Now we've got a word problem, and it says from a point on the ground, so let's call this a point on the ground, 25 feet from the foot of a tree. So here's our tree. This distance is 25 feet. The angle of elevation to the top of the tree is 32. Now what an angle of elevation is, you're looking with your eye. The angle of elevation is the angle you make by looking up or down. Elevation in this case is up from the horizontal. So the angle is this x value right here. That's your angle of elevation. So they're saying if a person looks up to the top of a tree from 25 feet away, then we have an angle of 32 degrees. And we want to know how high is the tree to the nearest foot. So again, this is a right triangle. Assume the tree is standing vertically, making a right angle with the ground. We have to identify these sides. So this is the side opposite that angle. There's your hypotenuse. We aren't using that. We're using the side next to the angle, which is our adjacent side. And tangent is the ratio we would use for that. Tangent 32 is equal to the opposite, which we don't know, x, over the adjacent, which is 25. Multiply both sides by 25. And we get x equals 25 tan 32. And that's equal to about 15.6. They said round to the nearest foot, so that's 16 feet. That's all we've got today. Write your lesson summary and answer the questions below, and we'll discuss more tomorrow.